Hello everyone, this is Mr. Kissinger. I'm just here to do a quick little video about prime factorization. This is how it was taught in the class, and so this will be a useful tool for students who need to see it again. It's also a really good tool for parents to see how it was also taught, so they can help their students at home. So let's go over this. It has a couple of big concepts in here that we're going to talk about. First, prime factorization is when we split a number into a string of its prime factors. So we take that number, we break it up as much as we possibly can until the numbers don't break up anymore. And I think the best way of showing this is just jumping right in and doing some examples. So here we go. Our first example is 18. So what I've taught students is when I look at this number, I see it's an even number. And this was the trick I did when I was in middle school, and I'm just going to do the same. I tell my students the same thing. If it's even, we're going to divide by 2. I know that's 2 times 9. And 2 is the only even prime number. So when I see a 2, I'm going to circle all my primes as I get them. Now 9 is broken up. This is a little tricky for some of us because we don't think it is, but it is. This is actually 3 times 3. So, and once we get there, 3 is prime. I'm going to circle those. So my final answer is 2 times 3 times 3, or 2 times 3 squared. That's the squared part means we're multiplying 3 2 times there. And so we're using exponents there to help us with that. We could always multiply it back to make sure we're right. 2 times 3 is 6. 6 times 3 is 18. And now we know we're correct. Let's go to our next example. Our next one is 25. So what I'm looking for here again is even numbers. This is not even, so I cannot take out the 2. So now I'm looking for 5s and 0s, and I see a 5. When I see a 5, that's great. That means I can divide by 5, and because of money, that makes life a lot easier. 5 times 5 is 25, and that's our answer. 5 times 5, or 5 squared. Those are our 2 answers that would be acceptable. Again, we're going to need to circle those primes as we see them. Our next example is a little tricky, and so let's take a look here. 31. When I'm looking at 31, I see it's not even, so I can't go by 2. 5 or 0, it doesn't end in 5 or 0, so I can't do that one either. So at this point here, I'm looking at it, and I'm seeing that, hey, 3 plus 1, this is called the 3 trick. So 3 plus 1 is 4. And if that worked out where it was like in the a multiple of 3, then I know it would be divisible by 3. A great example of that is 51. 5 plus 1 equals 6, which then tells me that 51 is divisible by 3. It's actually 3 times 17. But in this case, 3 doesn't work. And that really makes sense because 3 times 10 is 30, and then 3 times 11 just jumps right over at 33. 31 is prime. It's a prime number. I mean, there's other tricks to check for 7 and things like that, but that is just way too much. Way too much. I mean, we can remember those, but personally, I just do the 2, 3s, 5s, and I look for that and try 7 if there's nothing else. Our next number is 240, and this one is a great example of how we can use all of our tricks now. So 240 breaks up into 10 times 24. I see that 0 there, so I know I can take out a 10 and divide by 10. So 10 actually breaks up because it's even 2 and 5. I see a 2, I'm going to circle it. See a 5, I'm going to circle it because 5 is also a prime number. Now 24 breaks up, it's even, so I'm going to divide by 2. So let's do a 2 over there. And 12, I'm just cutting things in half. 12 is even, so I'm going to do 2 and 6. Again, another 2. Circle it. Last, I have a 2 and a 3. Now we're starting to see why they kind of call these prime factor trees, because if you turned it upside down, it would kind of look like a tree. But let's take a look at our answer here. We have 1, 2, 3, 4 2s. 1, 2, 3, 4 2s. There's 1 3 and 1 5. Or I can write it as 2 to the 4th power times 3 times 5. It's important to note that the numbers start small and they get larger as they go. That just makes it easier on everybody as you're trying to look at the answers. And also, we can always check our answer again. 2 times 2 is 4, times 8, 6. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3, 48, times 5 is 240, so I know my answer is correct. You can always check your answer and find out you're right. Here's our last example, 154. So I look at 154, again, it's even. Because it's even, I know I can take out a 2, so I'm going to take out that 2. And off to the side, if you don't know what that is and you can't do it in your head, don't feel bad. Just do a little quick division off on the side. 1, 4, do a little quick division. You got 77. Now I'm looking at 77. Let's see, and that'd be 14. I know that's a 0, so I know I'm done. 77, I'm looking at that number, and that looks to me like it's a number divisible by 11. Anything like 33, 44, 55, anything like that is going to be divisible by 11. So this is 11 and 7. I'm going to circle both of those. And this is actually 2 times 7 times 11 is the answer. There's no repeats in there, so everything's to the first power. I hope this was helpful. I hope these examples helped you understand prime factorization a little bit better. And parents, I hope you understand how I teach this now in my class. Thank you guys, and I hope you guys have a great day. Thank you.